probably September 13th.
Oh, time for another lovely class.
We don't care about the existence of a limit when a function is continuous. The only time limits would come into play is when you have a break of some sort. What are the types of breaks? The first one is jump. So we have seen this jump, this continuities happen with what type of function? Piecewise functions. The second type is an infinite discontinuity. We have seen that too. It happens with what type of functions?
I believe it was
Tangent.
I apologize, is a very much. I don't discontinuity as an asymptote or
A vertical asymptote. When does it happen? Or when does it happen?
oh, my apologies, when it's basically in the fact, meaning that what you're dividing by instead of the denominator is going to be.
If the denominator is 0, and it typically happens with a rational function or other types also. But as if we divide by 0, we will have an infinite discontinuity at some point. The last case is what we call a removable discontinuity. And the last case is trivial. In the sense, if you define the function in a different way, you can get rid of the discontinuity, which is why we call it removable. You can remove it. So it doesn't matter that much, but those two we need to consider. And there has to be discontinuity for us to worry about a limit. In other words, there has to be a break for us to think of a limit. Other cases, it will just work fine. The purpose we will talk about limits is to understand the idea of the derivative, because it happens at an instantaneous value. So that's where we are going, but let's understand limits first. Well, here's the question. I want to think about limits. I'd like to compute limits. What are the points of interest for me?
Where the brakes are. Huh? Where the brakes are.
Where the brakes, right? Well, Nick, like
Between 2 and 3.
who wants to live on the x-axis? 2 and 4. So a jump happens here. Jump in a different way happens there. But the brake is at 2, brake is at 4. So if we want to find the limit, those are the two places that I'm interested in, 2 points of interest. How do we compute that limit? Well, that is the notation. Lim stands for limit. X, the arrow means the approaches to. The first point of interest is 2. So I'm going to put 2. And put a minus as a superscript. That would mean from the left. So I'm going to approach 2 from the left, then from the right. So first up, I'd like to know what would happen from the left. So note that we are saying x is approaching 2 from the left. So I'll call that function f of x. So that would be the limit of the function f of x as you approach 2 from the left. I don't want to write this time and time again, which is why I have an effective way of writing it, simple notation, but the moment I see it, I understand what it's talking about. Okay. Approaching 2 from the left would simply mean I start at 0, I'm getting closer and closer to 2. Yes? Now, watch that marker. So as I get closer and closer to 2, what is happening to the value of y?
Increasing.
It's increasing and it is approaching 2. So as you move from the left-hand side, the function goes to 2. So approaching 2 on the x-axis from the left, the function is going toward 2. Good. Now, of course, there is the other side. Let's see, what would that notation mean? Oh, come on, there's more to it, just not from the right. You're right, but if someone asked you, well, I don't know anything about limits, could you explain that to me? And you responded from the right, would they understand? Okay. Getting closer.
X approaches 2 from the right.
And what are we trying to find?
Sure, what the value is of that.
Exactly f of x, or the limit of f of x.
The limit.
The limits of f of x. So what we're trying to find is the limit of f of x as x approaches 2 from the right. Good. Great. You may say, well, right, I've got a bunch of values, where should I start? You can start all the way from positive infinity, but since there is a break at 4, I can start at 4 and go to the right. But if this curve kept on going, you should probably start somewhere this side and slowly move toward 2. Good. So let's start at 4. And I'm going to get closer and closer to 2. Good. What happens to the value of the function? At 4, what is the value of the function?
2, 3.
3. Close dot. And what happens as you get closer and closer to 2? It stays the same. But at this point, it doesn't take on the value 3. Do you agree? Because it's an open one. So it stays at 3, but when it comes to 2, x, when it approaches 2, the value of y is not exactly 3 as you come from the right. But the limit is 3. See the difference? The value of the function and the limit of the function are different things. So and say in limits, it is going to be 3, but the value of the function is not 3. Good,
And that's because the jump is there.
because there's the jump and it's an open door. Good, okay. We'll keep going. And the other point of interest would be 4, yes.
Now, what if the circle is closed?
If the circle is closed, good question. Nathan?
Enzo.
Who?
Enzo.
Ends are close. So if that's a closed door, that is also a closed door, then you're trying to say, this is a value of a function, that is a value of a function, right? So one value of x, you have 2 possible y values. That cannot happen because it will fail the vertical line test. It is not a function to begin with, right? So there can only be one open dot and one closed dot because we're talking about functions. Good. Okay. The other point of interest is 4. Guess that might be with you.
Usually have your eraser on top of it.
Yeah.
I think it's behind the. Are you sure it's not behind there?
So I would like to find the limit of the function, not the value, as I approach 4 from the left-hand side. Good. Great. Flash last time. I want to approach 4 from the left, so there should be a start from the left. 2, right. I can start here, get closer to 4. At 2, what is the value of the function? 2. But as you go away from 2, what is its value? 3. So you are right here and you're going toward 4. What happens as you approach 4? At what value? It stays the same at what value? 3, right? 2, you're approaching 4 from the left, and it is going to stay the same and gets to the value 3.
X is equal to. Now, for approaching from the right, we could use 6. Not 6 at the very least, like there, but we're talking about the very least, like 6 is the stuck gap when it comes back.
So I'm going to start at 6 because that's why the next point is at. Of course, you can start at close to infinity. You start at 6, you're getting closer and closer to 4. What is happening to the value of y? And it's getting to 3. Negative mind. 2. So it's starting here, and as you move on the x-axis, the value of the function. Excuse me. The value it's reaching is 2.
The thing is, though, isn't 2 completely blocked off by the fact that we still have an open circle there, we can get.
That's why I'm not calling it the value of the function. I corrected myself. Right.
My apologies.
It's not the value of the function, it's the limit of the function, and specifically from the right-hand side. Are we clear so far? Yes. So what is the value of the function at 4?
3.
3. What is the value of the function at 2? 2. What is the value of the function at 0? What is the value of the function at 6? I didn't write it. Probably about 1.5 or 1. Right. Should have written it. 0.5. Good. Both of these limits, I've looked at them from one side, right? I found the value of this limit from the left-hand side, that one from the right-hand side. So that limit is what we call left-sided limits, and if you have to take a guess, what should we call the other one? Right-sided.
Less than 2.
Collectively, if I had to give it a name, I'll call them one-sided limits. Right side, left side, doesn't matter. But still I haven't defined the limit yet. I wanted to find the value or the limiting value for the function, which I haven't gotten to yet. So left-hand side, I put a minus, right-hand side, I put a plus. But if I just wanted the limit, how should I write it? Take a guess.
So when the approach is 4.
Just limit approaches 4. Do you want to guess the value? Is it 3? Is it 2? Is it triple now? Any thoughts?
It doesn't exist,
Doesn't exist. Why?
because the left side and the right side don't match. They're not the same value.
Kyle.
Lewis.
Rules, okay. So, actually, says that, okay? So 3, 2, does not exist. And commonly we would write it as DNE, which stands for does not exist. Now,
Wait, can you explain that?
yes, I'm guessing that. So the limit from the right hand side does not match the limit from the left hand side. Right? So so the right side limit doesn't equal the left side limit at x is equal to 4. So the limit does not exist at 4. So for us to say that a limit exists would simply mean the right and the left limit must be the same. And you may say, well, that's never going to happen. Well, it'll happen under one condition. Or two. Are we clear? Now, you tell me, what is the limit at 2? In other words, I'd like to find.
Would it also be just, or does not exist? I'm sorry, we're talking about-
That wouldn't,
Wouldn't exist, right? And why is that?
because they're not the same.
Because they're not the same. The left side limit doesn't match up the right side limit, so the limit does not exist. Are we clear?
Yep.